Hello, folks. Welcome back to MJ School of Mining and Geology. In today's session, we are focusing into the classification of clastic sedimentary rocks. You know that sedimentary rocks are classified um, into three categories. That is clastics, the chemical, and the organic sedimentary rocks. Wherein in the organic, we are focusing on coals. The chemical, we are focusing on the rocks such as limestones and dolostone, and clastic sedimentary rocks, common clastic sedimentary rocks. Today we'll be focusing on breccias and conglomerates, sandstones, siltstone, mudstones, and shale. Please don't forget to like, share, comment, and hit the notification button below so that you get notified once we upload new content. Stay tuned. Clastic sedimentary rocks are rocks that are formed from breaking down of pre-existing rocks. After those pre-existing rocks have been broken down, those clasts, all right, clast means pieces of rocks. They must be transported by agents of transportation. It could be a river, water, or river. It could be wind, it could be ice, different agents of transportation. And for as long as the agent of transportation have got sufficient energy to transport those materials, those clusters of varying sizes, ranging from, very fine materials to, gravels, all right, as long as that agent of transportation has got sufficient amount of energy, those clusters will be transported for as long as it takes, traveling away from its source or where they are coming from. It means if they're big enough, they won't travel that much because they will be dropped. All right, but if they're fine, they will travel for quite, a distance. And then when energy, or when the agent of transportation loses energy, then material get to be deposited in an environment of deposition. If you haven't yet visited our videos on the environment of deposition, please, you're more than welcome to visit that on MJ School of Mining and Geology, and the playlist of sedimentary, or sedimentology. All right. So now, after everything get to be deposited in the environment of deposition, they need to undergo what we call lithification, which I'm going to take you through in greater detail today. What is the process of lithification? That is wherein we'll be talking about compaction and cementation. All right, everything now get to be cemented and compacted into a rock, a solid rock. These are called clastic sedimentary rocks. So this is just to, make you visualize basically what's happening during the formation of sedimentary rocks. So for example, you can see over here that we the first thing is we must have a pre-existing rock. That pre-existing rock, it must undergo weathering. Different types of weathering. We're talking physical weathering, we're talking chemical weathering, we're talking biological weathering. So we've got different types of chemical of weathering. So once weathering is taking place, we now have these clasts or broken or pieces of rocks. These pieces of rocks, they would be transported by agents of transportation, and then get to be deposited in an environment of deposition. And then after that, lithification take place, where in compaction and cementation are taking place to form a solid sedimentary rock. Now, like I said, I promised I will take you through the basics of lithification, that is to say compaction and cementation. And let's start with the very basics, that is compaction. So compaction happens when the layers of sediments and build up on top of each other. Remember, you're depositing things, they are piling up on top of the other. So because of the weight of the overlying materials, these things, they would press each other down. When they're pressing each other down, what will happen is you are going to squeezing things out, all right? Because you're going to first thing squeeze the water out of the pore spaces. All right. Now, when you're squeezing water out of the pore spaces, you are making sure that now your clast get to be interlocked. All right, because you're pushing them closer to one another. So you're going to make these things to be well interlocked, making the rock or the sediments now to become denser and harder. But this is not completely solid. It still need the process of cementation, which I'm going to explain just now. So cementation happens when minerals dissolve in water. So we know a material like quartz, calcite, or calcareous, or an iron oxide, when they are in solution, you cannot see them with your naked eyes. But when they get out of solution, this material they precipitate, and enter into the pore spaces. By so doing, they crystallize and act like a glue, or they cement. All right, just like how the cement and concrete are taking place. All right, so we know cement, it binds things together. So it means this mineral-rich water flows through the compacted sediments. Then they would fill the pore spaces. This mineral bind the particles together, and then forming a solid rock. And then now you can see over here that we still have center particles or sediments, but now in between them we've got the pore spaces. So this gives us what we call porosity and permeability. Not forgetting that porosity is the amount of pore spaces in a volume of a rock, and the permeability is how interconnected the pore spaces are. This is the forms the very fundamental basics of the hydrogeology that we need for the occurrence of groundwater. We need this porosity and the permeability. But now, if you are squeezing these things together, if because of the weight of the overlying materials, you are basically going to make sure that the pore spaces, the water stored in the pore spaces, they're going to be squeezed out because of what you call compaction. And then what are you doing? You are forcing the grains to interlock. All right, to interlock. Then now after that, you come up with water-rich, mineral-rich solution that now the when those minerals they get out of solution, they get to precipitate and crystallize, and then now bind these sediments together, or these crystals together, and then that process is what you call cementation, making sure that now the rock, the sediments or the cluster are now solidified, or they um you know, they are into a hard sedimentary rock. And then now, most of the concepts that are usually confusing in sedimentology are these three. That is the roundness, the angularity, and sphericity. I think people they are confusing these things. But today, worry not, because I'm going to break these things down so that you no longer get confused. Let's start with the very basics, the angularities. So angularities, it basically talks about how sharp at the edges or the corners of the grains are. So it means if the corners of the grains are sharp, okay, like how copper a copper is, I get one of we call it the identification of copper, for example, is because of what you call jagged corners. All right, that's how we identify it, because it's like they can scratch you, okay, they can hurt you. So if the grains are sharp, all right, then we say these things have got angularity. All right, but if the corners are smooth, then we say these things, they are less angular, then it means they are rounded. All right, so it means roundness talks about smooth corners of the grains. If the corners of if we don't if the corners of the grains are very smooth, then we're talking about roundness. But if they are very sharp, then we're talking about the angularity. But now sphericity is it's a resemblance of a sphere, or that of a ball, how close the overall shape of the grain is, okay, to that of the ball. So it means if it looks like a ball, it means we're having high sphericity. But if it's long, flat, or needle-like, then it has got low sphericity. And we've got these to show you that. Look, let's look at these ones. All right, let's start with sphericity. Now, you can see that from here to there, all right, everything in here, all right, it's like the shape of a ball. They are close to the shape of a ball. Then it means that they are having high sphericity. But everything on top here, they are almost, flat and long and elongated. So they're not resembling that of a ball, that of the ball. So they have got a low sphericity. But now, in terms of roundness, we are checking the corners. If the corners are smooth, then we would say this is well rounded. So let's check over here. Let's check over here. Here you see that the corners are not that are sharp. The corners are sharp. So if they're sharp, we're saying they are very angular. Okay, we're checking the sharpness of the corners of the grain, so they are angular. But in between, the corners still there, but they are very moderate. But here we don't have all these corners. They've been chipped off. It means that these things now, they are now smooth. All right, if they are now smooth, these corners are now smooth, then we say we're talking about roundness. Please don't forget angularity and roundness. We are just checking the sharpness, or we are checking the sharpness of the corners. If the corners are smooth, then we're talking about roundness. And then if they are not that smooth, then we are talking about angularity. But sphericity is just the how the corners or how the grain looks like, how the grain looks like a ball. All right. So now, if we're to check now this sorting is basically it's like how you are sorting your laundry, white t-shirts together and then black ones together. You are sorting them. So it's how uniform the grain sizes are. So if something is well sorted, it means the grain sizes are almost the same. If it's poorly sorted, it means it consists of a variety of grain sizes. And then now, if it's moderately sorted, it means the grain sizes are similar but not identical in size. All right. So here we showing you the concept of sorting. So you see here the grain sizes are almost of similar size, so they are well sorted. And then here moderately sorted, because they are not that bad. All right, so we are having moderately sorted grains. But here over here it's poorly sorted because we've got big materials. We've got small materials, so it's like you've got gravels, you've got sand particles, you've got mud particles occurring together. For example, if you want to know a poorly sorted a rock, we're talking about conglomerate and breccia. And we can also be talking about diamictites, because diamictites, remember, they deposited by a glacier, and we know glacier, when it deposits the materials, it deposits them all together, or at once. So because of that, it means all different types of sand sizes, or sediment sizes, they are going to be deposited together, then occurring together, then giving that a diamictite, which is a poorly sorted rock. All right. So basically, that's what sorting is all about. Then now, basically, this sorting, it tells us much about the where you're depositing, and how or basically the mode of transportation. For example, if we're having if you are having the river, okay, if you're having when the river is still having sufficient amount of energy, it will be able to transport all sort of sediments. But immediately when it's losing its energy, you will deposit fine material first, big material first, and then moderate ones, and then fine material later, because fine materials they need to where the environment is very quiet. All right, so they basically that it will give you sorting. All right. So I hope it you're getting the gist of it. And then another concept that we need to understand is the grain size. All right, is grain size. If we are having the gravels they will give us conglomerate and breccia, and then center particles they will give us a sandstone, and silt particles. So silt basically it's between sand and mud, or sand and clay, so it's silt. So it fills, if you're feeling it with your fingers, you'll feel a scent grits, so but it's still very fine. All right, so that's why we're saying it's between sand and clay. And then with the clay or mud, if you are feeling it with your finger, you are not feeling any grit in your finger, so it's very smooth. It's very smooth, so then you know that you are dealing with a clay material. I mean, guys, these things they don't need to be cramped, but to be understood. So if you are feeling this with your finger, if you can tell that this is sand particles, and then clay, you won't feel anything. Okay, then now, but now according to Wentworth scale, for example, Wentworth scale, you can classify these things. All right, so these are pebbles, what forms the conglomerates and breccias. And then we've got so pebbles, they range from between 4 millimeter and 64, granules between 2 and 4, and then these gravels, what did they give, or what do you call conglomerates and breccias. And then now we've got sand particles. Sand particles, they range from very fine sand to a very coarse sand. Very coarse sand, it means you can see that this thing is very coarse. You can see with your naked eyes that this is a very coarse sand particle. And then very fine, you can still feel the grit or it still feels you can still feel the roughness in your finger, inside your finger, or with your finger. But now you can still see that this thing is very, very fine. But now when you can't feel anything with your finger, then it means you are talking about mud particles. All right, and then particles, they are less than 0.063 millimeters. Then sand particles, they ranges from 0.063 all the way to 2 millimeters. All right. When I was still doing my second year, my lecturer would want us to understand these grain sizes with but to know these things day and night. All right, so you need to know these sizes. So let's now talk about the most common clastic sedimentary rocks. All right. Oh, but before we talk about that, let's understand how clastic sedimentary rocks are classified. They're classified according to grain sizes, which we just dealt with recently. So we'll be talking about clay, silt, sand, gravels, that is gravels and boulders. Boulders are that big chunk of rocks, all right, or of class. And then we're talking about sorting, we dealt with, and then shape of the particles, roundness, angularity, and sphericity. We talked about that. So that's basically how today we're gonna classify our clastic sedimentary rocks. And so the most common clastic sedimentary rocks that we're gonna talk about today is conglomerates. So we know conglomerates and breccia. So the in terms of the grain sizes, they are all gravels. And then conglomerate, it will be heavy and rounded clast, and then a breccia, it will be heavy angular clast. That's the difference between the two. But in terms of sorting, all of them, they are poorly sorted. Then sandstone, it will be heavy sand particles. All right, and then it can either be well sorted, poorly sorted, or moderately sorted. Then siltstone, mudstones, shale, all of them, they are well sorted. All right, basically, especially mudstones and shale, they are all well sorted because they're made up of mud particles. But when you are differentiating them, mudstone breaks in the blocky way, and then shale breaks in the form of layers. All right, and I'm gonna explain this thing in details. So I wanna tell you these steps that when you're in the field, guys, you are a geologist. You need to know all these rocks. You don't need to be when you're in the field, not being able to differentiate between granite and sandstone, or a nice sandstone and granite. You need to know all these kind of rocks. I mean, when you are in the field, the very basics is, if you want to know that you are dealing with sedimentary rocks, we are looking for layers, all right? And then if you need to know as to whether you're dealing with, and also structures, you can identify these things through structures, cross bedding, and many other things. But if you want to know that you're dealing with metamorphic rocks, and if you haven't yet visited our videos on identifying metamorphic rocks, you are more than welcome to visit that on MJ School of Mining and Geology, to deal with how you are identifying different metamorphic rocks. But metamorphic rocks, you're basically looking at foliations, all right? You're basically looking at foliations. And then igneous rocks, basically, that those are crystalline. So, but for sedimentary rocks, all right, when you're in the field, you first look at grain sizes. You start here. Look at the grain sizes. Can you see individual grains with your eyes? If yes, and are they bigger than 2 millimeters? If they're bigger than 2 millimeters, then you know that you're dealing with conglomerate or breccia. But how do you differentiate between conglomerate and breccia according to the shape? All right. If they are rounded, it's conglomerate, and then if they're angular, it's breccia. And then if yes, and they are cent sized, then it's sandstone. If no, you're not seeing this thing with your naked eye, then it could be siltstone, mudstone, or shale. And then these things, shale, it will be in the form of layers, all right, like pages of your book. And then mudstone, it will be in a blocky way. And then siltstone, you'll still feel a little bit of sand particles inside that. Okay. Then, if its coarse, greater than 2 millimeter, check the shape, whether it's rounded or angular. Then, if it's sand-sized, check texture and color. All right, rough, gritty texture, it's sandstone. Look for these cross-bedding, these ripple marks, to confirm the sandstones. So these things um basically how you classify sandstones. All right. So if you haven't yet visited our video on classification of sandstone, you are more than welcome to do that on MJ School of Mining and Geology. If very fine mud or clay, check how it breaks. If it breaks into thin layers, it's a shade. If it breaks into blocky chunks, it's mudstone. If it's slightly gritty, it's a siltstone. So let's start with the conglomerate. Conglomerate, you can see here, conglomerate. The mistakes that people are making is they are checking the overall shape, okay, of the rock. No, we are not checking overall shape of the rock, but we are checking the materials inside, how, as to whether they are smooth, or they are angular. If they are angular, it means it's breccia. If they are smooth, it means these are conglomerates. We are checking how smooth the materials are. If they are smooth, then we know they are rounded, then we're talking conglomerate. If they are not smooth, they are sharp, okay, then we're talking about the angularity, then we're talking about breccia. And then all this is because of the mode of transportation. If this is the source, and you find material closer to the source, it means you'll be having angularity. All right, you will having angular clast. This is because the materials were not transported for a quite a period of time. It means they did not have enough time for the corners to be chipped off. But if the transportation is far away, all right, from the source, then it means the materials, the corners were chipped off as time goes by. That's why now they are rounded. So that's why with the conglomerate, it tells us that the materials, they've been transported for a longer period of time, but for the breccia, the materials, they've been not been transported for a longer period of time. Then with in terms of conglomerates, we've got two types of conglomerate. We've got what we call cluster supported a conglomerate. We've got cluster supported conglomerate, and we've got what we call a matrix supported conglomerate. We've got matrix supported conglomerate, matrix supported conglomerate. Now, what's the difference between the two? With the matrix supported, it means if this is a conglomerate, if this is the conglomerate, these are those materials like this, these are those gravels like this. Between these white materials will be the matrix. It means that these clasts, they are supported by the matrix throughout the entire volume of this conglomerate. But if they are cluster supported, it means we don't have much of the matrix, but the clasts are touching each other. So we have less of the matrix, but the cluster are touching each other. So this is the matrix supported conglomerate. All right. So I hope you understand the difference between conglomerate and breccia. So can you see that these materials, they are poorly sorted? They are poorly sorted because they've got different sizes. So you've got bigger, you've got gravels, you've got sand particles, you've got mud particles as well. So you've got um, different ranges or ranges of particles. So that's why we're talking about poorly sorted materials. All right. And so I hope you understand. And then the another group of classification, it will be the sandstones. Like I said, if you haven't yet visited our video on classification of sandstones, you are more than welcome to do so. So the sandstones, you can be talking about arenites, wackies, and mud rocks. For the detailed version of it, please visit our video on classification of sandstone. All right, but like I said, sandstone, can you see with your naked eye that these are sand? Even if you were to zoom in with your what do you call this, with your hand lenses, you can see sand particles. All right, you can see sand particles. So you now know that you're dealing with a sandstone. You can see these are sand particles, and you can with the feel, you can see that this is rough and is is sandpapery. All right, so that's how it falls. So sandstones, like I said, they can be, well sorted, they can be moderate, or they can be poorly sorted. But in terms of grain sizes, they all contain in sand sizes or sand particles. All right, I hope you get this. But now another things that can help you identify these things are sedimentary structures such as ripple marks, cross beddings, and many other yeah, basically cross beddings and ripple marks. They would help you to identify these things. All right. For example, if you were to go to Karoo, a Karoo basin, you would see a lot of ripple marks and cross bedding. So basically, that will help you to know that these indeed the sand materials. All right. So like for example, types, like I said, how sandstones are classified. Sandstones are classified based on yeah, the composition. In terms of composition, we'll be having a quartz sandstone, alcoves, keys. So the environments will be rivers, dunes, beaches, shallow marines. So these are the types of sandstones: quartz arenite, having a high amount of quartz. We've got alcoves. If you can check here, alcoves. Can you see here? Alcoves. It's a lot of feldspar. Lithic. It will be having lithic materials. All right, course, a lot of false pass. All right, gray waki, it means it's unsorted. Gray wakis are unsorted. That's why when we're talking about, for example, when we're looking at the Barberton greenstone belt, we know in the fig tree, that's where we are finding these gray wakis inside the trenches, because now those things they were deposited by, by the what do we call this, wherein materials avalanches kind of vibes. Yes, that's what brings what you call the greyworkies, the unsorted, because they were deposited all at the same, or at the same time. Then lithic arenites, because we have got the lithics inside. Can you see we have got lithics materials? These are, for example, quartz materials, for example. So you have got feldspars and many other things. So these are lithics. So this is a lithic arenite. So calcareous sandstone, it means if you were to pour acid here, then you would see that the acid, the reaction with acid, then you know that we're having calcareous sandstone, but it will still be having sand particles, for example. And ferruginous means it's having iron materials. All right. I hope you are understanding these things. And then when you're in the field, you won't be, you won't be I'm confused. And silt materials, these are the materials that ranges between 0.004 to 0.000625. That is the materials between sandstone, sand particle, not sand particles, but clay and um, sand. All right. So I hope you understand. So this is very fine. So don't forget. That it will still you will still it will still feel you'll still feel a little bit of scent if you are trying to feel it with your fingers. You'll still feel a little bit of scent, but this thing is very, very fine. All right, it's very fine. So that is silt, and it's well sorted. It's still smooth, but slightly gritty between mud and sand. All right, I hope you understand this. And even if you were to check this with your what do you call your um hand lens, you will see this thing when you're in the field. You will see, please do that, move around, look for cell phone, and then look with that a hand lens to get the gist, to get the difference between sand and salt. All right, and mudstones and shale. Shale is the one that is very shale and mud. They are easy to differentiate because for shale you are looking for facility, which is why when you are metamorphosing shale, it will give you a slate, and slate it's still having this facility inside. So it's like a pages of the book. You can easily, when it breaks into these thin layers, then you know that you are dealing with a shale, and the shale is very soft. All right, so it's very fine, and then very well sorted. All right, laminated, papery, and thin sheets. All right, and obviously because it's very fine material, it needs the environment that it's very quiet. So you deposit these things in a quiet environment. All right, that's why it's bringing in these very fine materials. And then mud is still very fine, and it's still very well sorted, but when it breaks into blocky or chunks. Can you see that now here? You're not going to break this thing into laminated material or into thin layers, but into blocks. All right, into blocks. All right, I hope you understand these things. And then, yeah, basically that is that. This will bring us to the end of our lesson. I hope you understood how we basically classifying the clastic sedimentary rocks. And today we looked into the most common clastic sedimentary rocks, that is the conglomerates and breccias. Sandstones and mudstones, shale and siltstones. And then now, for now, I hope when you are in the field, you won't be, confused if you were to, come across the clastic sedimentary rock. And you know what I'm about to say. Enjoy the rest of your day, and cheers.